Hello everyone, so today's video is going to be on how to find the square root of any number without a calculator, especially an integer. So anyways, ideally you would have to have a calculator to find the square root of a number that's not, say, a perfect square, but let's say you have an exam or something, you forgot to bring your calculator, then you're screwed for that question, unless of course you have some way to calculate it, even if it's not as precise or as quick as a calculator. But a calculator would still be ideal. So I'm just going to pick a random integer that's not a perfect square. Let's say 7. I could choose a bigger integer, but for the sake of time, I'm just going to use a smaller one. And yeah, so 7 is, we want to find the square root of 7. So 7 is the integer that we're going to focus on. And so for this trick, which doesn't need a calculator, all you have to do first is find the perfect squares that are directly below and directly above 7. So for instance, we have 1, 4, 9, 16, and so on. And obviously 7 is between 4 and 9. So we have 4, and then we want to find the square roots of these. So for this, it's obviously 2, and then for 9, it's 3. And yeah, obviously you don't need a calculator to find these out, but I'm just going to write it down like that for emphasis. Okay, I don't know what happened there. Um, that's weird. So yeah, anyways, so now that we have 2 and 3, what we want to do is we want to write like a number line like this. So we know that because 2 squared is 4 and 3 squared is 9, that the square root of 7 has to be somewhere between 2 and 3, which is obvious. And so first what we want to do is we're going to take the average of 2 and 3, which is obviously going to be 2.5, which is not the square root of 7, but you'll see why we're using 2.5. And next you want to find what 2.5 squared is, which is just 6.25. And if you don't have a calculator, there's two ways to compute this. The first is you could realize that 2.5 squared is just 25 over 10 squared, which is just 625 over 100. Or you could also say 2.5 is the same as 5 over 2. And if you square this, that's just 25 over 4. And either way, you should be arriving at 6.25. Okay, so great. So now we know that 2.5 squared is 6.25. But the important thing to know is obviously that 6.25 is less than 7. And why is this important? Well, since we know now that 6.25 is less than 7, we know that the square root of 7 has to be greater than 2.5. So now we can get rid of this 2, and now we can move in 2.5 here because we know that it's greater than this. So even though we know the square root of this has to be an irrational number, we can still converge on it by narrowing the bounds, which is nice. And so the strategy to get this is recursive. So again, we can take the average of these two numbers, and if we do that, we get 2.75. And then we can find 2.75 squared. And I actually don't know this off the top of my head, so I'll just calculate it. So we know that this is the same as 2 and 3/4, which is the same as 11/4. And if this is squared, That's 121 over 16, which is 7 and 9/16. And we don't need to calculate it all the way out because we already got the important thing, which is that this is greater than 7. And if this is greater than 7, then and 2.5 is less than 7, then we know that this has to be, this can replace the 3 now. So have the eraser again. And we write 2.75 here. So we started off knowing that it was between 2 and 3, and now we narrowed it down to knowing that it's between 2.5 and 2.75. And again, we can take the average of these two. And if we do that, we get 2.625. And again, we can square this. And so 2.625 is just 2 and 5/8, which is 21 over 8. And squaring this is 441 over 64, which is actually, and we know this is less than, let's see, 448 over 64. And 448 over 64, the reason I chose 448 is because this is the same as 7. So we don't even need to know like the actual value of this. We just need to know, is it less than 7, or is it greater than 7, or is it 7? And it's less than 7, which means that this is the new lower bound. So then what we can do is erase all this. And so now this is 2.625. And again, we can take the average of these two bounds. So we have the average of 2 and 5/8 and 2 3/4, which is the same thing as 21 over 8 plus 22 over 8, which is just 43 over 8. Since we're taking the average, then it's 43 over 16. And let's just erase all this. And so now 43 over 16 squared. 16 squared is 256. And 43 squared is 43. What is 43 squared? Let me see. 1720 plus 129. I think that's 1849. So this is 1849, and 7 is just equal to 256 times 7 over 256, which is 1792 over 256. So we know then that this is less than that. Wait, no, it's the other way around, sorry. This is greater than that. So now we can replace, sorry, so now we can replace this with 43 over 16, which is just 2 and 11 over 16, which is just, let's see, 2 and 5/8 plus 1/16, which is 2.625 plus 0.0625, which is 2.6825. Okay, so now we really narrowed it down because we started off saying it was between 2 and 3, and now we know it's between 2.625 and 2.6825. And I could just keep going on and on. I think you get the gist of it. And I think I'll just find the average one more time, and then I'll calculate it to see how close it is to the actual answer. So if we subtract these, just a gap of 0.0625. And so the average would just be 2.625 plus 0.03125, which is 2.5625. And so we'll say that the square root of 7 is about 2.65625. And now I'm just going to check my phone's calculator to see what the actual square root of 7 is. And obviously it's irrational, but I'm going to see what a good approximation is. Wow, okay, so the phone calculator says that the actual one is 2.6457513 ... And as you can see, it's pretty close. Like it's basically less than 0.01 apart. So if you don't have a calculator, then this technique of just using averages recursively is actually pretty decent, especially with smaller numbers. Obviously, with a bigger number, it would be more of a pain, but it still does the job. So yeah, it's pretty accurate.